Hello and welcome to this short introduction to core concepts of the Nix package manager for reproducible data science. My name is Bruno Rodriguez, and I am the author of two packages that leverage Nix, two R packages, Rix and Rixpress. This video should help you understand certain core concepts that I believe are really important if you want to use Nix for data science. So there are three ideas that I want to discuss. Derivations, the dependencies of these derivations, and then the Nix store and hermetic builds and what that means. So what is reproducibility? So this is really the starting point, and this is really why we use Nix, is because it's a package manager that focuses on reproducibility. So ideally, if you have the same code and the same data, you get the same results. You need for this a consistent and reproducible computational environment, but these environments vary across machines, and this is where Nix helps. However, it's not just about the same code and the same data. It's also about the same execution steps. So you need to be able to rerun your analysis in the same way that it was done originally. And here Nix can help as well. So Nix is often introduced as yet another package manager, but it is a bit more than that. It is a tool for complete reproducible builds, end-to-end tool. And the build can be a program, it can be your data science pipeline, it can be a paper, it can be a model, model weights, and so on and so forth. So what is a derivation? So a derivation is essentially a recipe for building outputs. It defines the inputs, it can be data, it can be software, it defines the steps, and it defines the output path, so where the derivation is going to store the results. It is entirely deterministic, meaning that if you give the same inputs, you will get the same outputs out. So this is an example derivation written in Nix that uses the awk tool to filter some rows in a CSV file. And this is actually a functioning derivation. The only thing here that is missing is the link to the Nix tarball that I replaced here with 3 dots. But apart from that, it is a functioning derivation. So this will install Gawk and make the awk tool available to you in your environment, and you will be able to process the CSV file. This is a derivation that will always work exactly the same way on any operating system and on any environment that you will run it. What is important is that you need to absolutely declare all the dependencies. So these inputs, include data files, the software, R packages, or Python or Python packages, configurations, environmental variables. It doesn't matter. All of this needs to be explicitly declared because the derivation is going to run and it's going to be built inside a hermetic sandbox. So all of this together, the derivation, the inputs, the dependencies, and the dependencies of the dependencies, and so on, is a so-called component closure. It's the complete set of dependencies. And in this example, it would be R, or awk with some system libraries, and so on and so forth. And this ensures portability. So this is a figure from the seminal paper by Alco Dalstra that explains this concept. And so here you see subversion, and you see some dependencies of subversion, and you see how all of this, it forms a component closure. So the Nix store, this is where the build outputs are stored. They have unique paths with hashes. So each tool that you build or each data set that you process will end up there with a unique identifier. And the hash reflects the inputs and also the build process itself. And it makes, so this hash uniquely identifies every output. So if you change anything in the input, the output will also be different. So I already mentioned hermetic builds. So these are the isolated sandbox for builds. Only declared dependencies are allowed. No external influences like a connection to the internet or environmental variables that you set on your computer will have any impact. They will not, they will not leak into this sandbox, and this guarantees determinism. So you are sure that nothing on your system will have any impact on the build process. Finally, Nix is a very powerful tool, but it is a tool that is difficult to get into. So Rix and Rixpress are two packages that I wrote, two R packages. So Rix allows you to define reproducible development environments in the Nix language using simple R code. And Rixpress allows you to define reproducible pipelines as a composition of pure functions or as a composition of pure steps. So for example, you start from empty cars and you pass it through F and then through G and so on. And F and G, of course, can be any type of function at all. It auto-generates an X expression, and then these two packages together allow you to take full advantage of the reproducibility offered by Nix without being a Nix expert. So in summary, Nix ensures reproducibility via derivations, explicit dependencies, hermetic builds. It's perfect for data science, and Rix and Rixpress allow you to take full advantage of Nix. So to know more, check out Rix and Rixpress's website. Rixpress is still in early development, but it can already be used to get familiar with the concept of reproducible pipelines with Nix. And I will link also two other videos, a 5-minute intro to Rix and a 5-minute intro to Rixpress. Thank you.